Have you ever wondered if two particles separated by vast distances could instantly communicate? Welcome to the world of quantum entanglement. It's a realm where the rules of classical physics are tossed aside and a new peculiar set of laws reigns supreme. Quantum entanglement is a strange phenomenon that occurs when two or more particles become inextricably linked, and the state of one directly influences the state of the other, no matter how far apart they might be. To understand this, let's venture into the realm of quantum mechanics, the theory that describes the tiniest particles in the universe. Quantum mechanics is unlike anything we experience in our day-to-day lives. It's as if we've stepped through a looking glass into a world where particles can exist in two places at once, move forward or backward in time, and even teleport through impenetrable walls. This isn't the straightforward, predictable world of classical physics we're used to, where an apple will always fall to the ground and the moon orbits the Earth in a predictable pattern. Now, imagine two twins separated at birth. They grow up in different continents, unaware of each other's existence, yet when one feels joy, the other also feels joy. When one is hurt, the other also feels the pain. They are bound by an unseen, unspoken connection, a mysterious bond that transcends time and space. This, in a nutshell, is quantum entanglement. However, instead of twins, replace them with particles like electrons or photons. Now, when we measure one particle, the other, no matter how far away, will instantaneously respond. It's as if these particles are communicating faster than the speed of light, something that was thought to be impossible according to Einstein's theory of relativity. So in essence, quantum entanglement is like having two twins separated at birth who still feel each other's emotions no matter the distance. Intriguing, isn't it? Now that we have a basic understanding of quantum entanglement, let's delve deeper into its mechanisms. Quantum entanglement is a peculiar phenomenon that is deeply rooted in the principles of quantum mechanics. Among these principles, two stand out: superposition and measurement. Superposition is the principle that allows particles to be in multiple states at once. Measurement, on the other hand, is the act of observing these particles, causing them to collapse into one state. To better understand this, let's imagine a coin toss. As the coin spins mid-air, it is simultaneously in a state of being both heads and tails. This is akin to the superposition principle in quantum mechanics. The coin, much like our quantum particle, exists in multiple states until we decide to catch it and observe the outcome. And here is where the magic of quantum entanglement comes into play. Let's say we have two entangled coins, one in London and the other in New York. According to quantum mechanics, the moment we catch and observe the coin in London as heads, the coin in New York instantaneously becomes tails, no matter the distance. In essence, the act of measuring one particle influences the state of its entangled partner, and this happens faster than the speed of light, defying our traditional understanding of space and time. This is the heart of quantum entanglement. It's a mind-bending concept that has intrigued scientists and philosophers alike. It challenges our perception of reality and opens up a realm of possibilities that seems straight out of a science fiction novel. However, it's crucial to remember that quantum entanglement doesn't imply any form of telepathy or faster-than-light communication. It's a complex dance of probabilities and observations, deeply rooted in the mathematical framework of quantum mechanics. Just as the outcome of a coin toss is uncertain until observed, so too are the properties of entangled particles. Quantum entanglement sounds like science fiction, but it's real. It's happening right now in labs across the world. And it's not just theoretical physicists messing around with equations on a chalkboard. We're talking about tangible experiments that demonstrate the bizarre and counterintuitive nature of our universe. Let's rewind to the 1980s. In a lab in France, physicist Alain Aspect and his team are about to stun the scientific community. They set out to test the predictions of quantum mechanics, specifically quantum entanglement, using a pair of particles of light, or photons. Their experiment involved creating pairs of photons that were entangled, meaning that the state of one photon was instantaneously connected to the state of the other, no matter the distance between them. This was a direct challenge to Einstein's theory of relativity, which held that nothing could travel faster than light, not even information. To test this, Aspect and his team sent the entangled photons in opposite directions to detectors placed several meters apart. The detectors were set up to measure the polarization of the photons, a property that could take one of two values. The twist? The orientation of one detector was changed while the photons were in flight. Now, if the world was as straightforward as Einstein's relativity suggested, the outcome at one detector should not depend on what was done at the other. But that's not what happened. The photons knew about the change at the distant detector and adjusted their behavior accordingly. They remained entangled, just as quantum mechanics predicted. This experiment and others like it provided solid evidence that quantum entanglement is a real phenomenon. The results were so shocking that they sparked a flurry of further research and debate that still continues today. Quantum entanglement is perplexing. It defies our everyday logic, and it challenges the very foundations of our understanding of the physical world. These experiments have not only confirmed the existence of quantum entanglement, but they've also challenged our understanding of the physical world. Quantum entanglement is a complex subject, and with complexity often comes misunderstanding. Let's delve into some of the common misconceptions and surprising facts about this mysterious phenomenon. One of the most widespread misconceptions is that quantum entanglement permits faster-than-light communication. It's easy to see why this idea has taken hold. After all, two entangled particles can instantaneously reflect each other's state, no matter the distance between them. But it's crucial to note that while the correlation is immediate, it doesn't allow for information to be sent instantly. This is because until you measure a particle, you won't know its state, and hence you can't control it to send a specific message. Another common misconception is that quantum entanglement defies the laws of classical physics. However, it doesn't break these laws, it simply operates outside of them. Quantum physics is a different playing field, with different rules. It's like playing chess on a three-dimensional board. The pieces don't move in the traditional way, but that doesn't mean they're breaking the rules of chess. They're just playing by a different set. Now let's shift gears to some surprising facts about quantum entanglement. Despite its abstract nature, it has some very practical potential applications. One of these is in the realm of quantum computing. Quantum computers use the principles of quantum entanglement to process vast amounts of data simultaneously. This could make them exponentially more powerful than today's most advanced supercomputers. Another surprising application is in quantum cryptography. Through quantum entanglement, it's possible to create a secret key that can encrypt and decrypt messages with absolute security. Any attempt to eavesdrop on the key would disrupt the entanglement and alert the communicating parties to the intrusion. Quantum entanglement isn't a method for instant communication, but it could revolutionize how we store and secure information. It's a fascinating realm where reality appears to outstrip even the wildest flights of science fiction. Quantum entanglement is more than just a scientific curiosity. It holds immense potential for the future. Imagine a world where computers perform calculations at speeds currently unimaginable, where messages are encrypted so securely that they are virtually unbreakable, and where teleportation isn't just a concept confined to the realms of science fiction. All these could be possible thanks to quantum entanglement. Let's start with quantum computing. Traditional computers use bits, which can be either 0 or 1, but quantum computers use quantum bits or qubits, which can be both 0 and 1 at the same time, thanks to a quantum property known as superposition. Entangled qubits can be in multiple states at once, giving quantum computers the potential to process vast amounts of data simultaneously. This could revolutionize industries ranging from healthcare to finance, making complex calculations a breeze. Then there's quantum cryptography. Today, we rely on complex mathematical algorithms to encrypt our data. But if quantum computers become a reality, they could easily crack these codes. That's where quantum cryptography comes in. By using entangled particles, we could create codes that are virtually unbreakable. Any attempt to intercept the message would disrupt the entanglement, alerting the sender and receiver to the intrusion. And finally, teleportation. It might sound like something straight out of Star Trek, but scientists have already used quantum entanglement to teleport information from one particle to another. This doesn't mean we'll be able to teleport humans anytime soon, but it does open up fascinating possibilities for how we could transmit information in the future. Quantum entanglement might sound like a concept from a sci-fi movie, but its potential applications could make it a reality sooner than we think. As we continue to unravel the mysteries of the quantum world, who knows what the future might hold?